I'm Jesse Berezovsky, and I'm a professor of physics at Case Western Reserve University. And I'm going to tell you about a new idea about how we can understand how the ordered structure of music emerges from the general chaos of sound. You can think of music as art made out of sound, but not just any sounds. Music is almost always composed according to a fairly strict set of rules, choosing from a predetermined set of particular sounds. So, why is music composed according to so many rules? For example, pitches are almost always divided up into octaves. And then, for example, in Western music, we divide the octave into 12 pitches. And of those 12 pitches, we often choose 7 to form a scale. So why do we organize sounds in this way to create music? To address that question, we can borrow methods from a related question, which is how do atoms in a random gas or liquid come together to form a particular crystal? For example, how do these silicon and oxygen atoms know to come together to form this crystal that's a particular kind of quartz? We know that the physics of phase transitions comes about because of a balance between energy and entropy. So similarly, we can look at a competition, a balance between dissonance and entropy of sound, and see that phase transitions can also occur from disordered sound to the ordered structures of music.
We start with a disordered array of notes, where each of the notes have a color that corresponds to its pitch within an octave. Then we can let the system evolve, and we see that order starts to emerge in the form of regions of different pitches. If we arrange these notes by pitch, we can see that in the case of disordered sound, there's no discernible pattern. But in the case of the ordered pattern of notes, we see that the pitches have arranged themselves into 12 discrete pitches, just as we do in traditional Western music. What's more, nearby notes form the pitches of familiar scales, and the junctions between regions of different pitches form familiar chords.
So this was just a first demonstration that this model can shed light on the structures of harmony in Western music. But we can take it further. These ideas could provide a new lens for studying systems of tuning and harmony across cultures or throughout history. You could use them to analyze the structure of a particular piece of music. You could use this idea to optimize the sound or timbre of an instrument, or even to create new musical instruments. Composers could use these ideas as a roadmap for exploring new ideas of tuning and harmony. And we can all use these ideas as a new way of appreciating music and seeing how the sort of emergent beauty that occurs in things like snowflakes or gemstones also occurs in the structure of music.